In the grand calculus of the Second World War, there is a variable that Axis strategists consistently and fatally underestimated. They understood tonnage, they understood caliber, they understood horsepower, but they did not understand the industrialization of terrain. To a German field marshal or a Japanese admiral, an airfield was a fixed geographic asset. It was a massive civil engineering project requiring weeks of surveying, months of grading, and thousands of tons of concrete or asphalt. In their military doctrine, air power was tethered to the earth. If you controlled the few flat, dry spots on the map, you controlled the sky. If the autumn rains came and turned the Russian steppes into a quagmire, the Luftwaffe was grounded. If the jungle reclaimed the coral strips of the Solomon Islands, the Imperial Japanese Navy Air Service was paralyzed. This was the hubris of the Axis, the belief that the earth itself, the mud, the sand, the swamp, was a neutral arbiter of war. They believed that the laws of soil mechanics applied equally to everyone. They calculated that the sheer difficulty of building runways in the most inhospitable corners of the globe would limit the Allied advance, creating a natural defensive perimeter that no amount of industrial capacity could breach. They were wrong. While the Wehrmacht was still relying on horses to pull artillery through the freezing mud of the Eastern Front, and the Japanese were using manual labor to hack runways out of the jungle with pickaxes, the United States Army Corps of Engineers was preparing to deploy a weapon that would render geography irrelevant. It was not a bomb. It was not a new fighter plane. It was a steel plank. Specifically, a piece of 10-gauge, low-carbon steel, 10 feet long and 15 inches wide, punched full of holes like a piece of industrial Swiss cheese. To the casual observer, it looked like scrap metal. To the logistician, it was the mundane savior of the air war. Officially, it was known as pierced steel planking, or PSP, but the men who laid it down in the sweltering heat of Guadalcanal and the freezing mud of Bastogne knew it by the name of the obscure North Carolina railroad stop where it was born, Marston Mat. Over the course of the war, American industry would stamp out 2 million tons of this steel, enough to pave a highway from New York to Berlin. This is the story of how a simple, interlocking steel sheet defeated the mud, conquered the coral, and allowed the Allied air forces to bring the apocalypse to the doorsteps of Tokyo and Berlin. To understand why Marston Mat was a strategic necessity, we must first look at the physics of 1940s aviation. The war had driven a massive spike in aircraft weight, creating a crisis of ground pressure that threatened to ground the entire U.S. Army Air Force. A world war. A fighter plane weighed perhaps 2,000 pounds. It could land on a cricket pitch, a cow pasture, or a hard-packed dirt road without sinking. But the new generation of American heavy bombers, the B-17 Flying Fortress, the B-24 Liberator, were Leviathans. A fully loaded B-24 weighed over 60,000 pounds. When that aircraft touches down, it is hitting the ground at 90 miles per hour. The kinetic energy is immense. The ground pressure exerted by the main landing gear is enough to turn hard-packed dirt into a trench and soft grass into a trap. If a bomber sinks even 6 inches into the mud, it cannot take off. It becomes a 30-ton paperweight, vulnerable to enemy strafing and useless to the war effort. In 1939, the United States Army Air Corps realized they had a catastrophic problem. Their emergent doctrine called for forward air, power-moving bombers and fighters close to the front lines to support the infantry and strike deep into enemy territory. But building a concrete runway capable of supporting a B-17 took 3 to 6 months. In a war of movement, where front lines shifted 50 miles in a day, 3 months was an eternity. The Army needed a runway that could be built in days, not months. It needed a surface that could support 60,000 pounds of impact, but was light enough to be carried by 2 men. It needed to be modular, repairable, and virtually indestructible. The Nazis had experimented with wire mesh, similar to heavy-duty chicken wire. It failed. It tore under the torque of heavy engines and provided no flotation over mud. The British tried Sommerfeld tracking, a bamboo and wire contraption. It was too fragile for sustained bomber operations. The French utilized a heavy steel chevron grid, but it was cumbersome and difficult to transport. The solution would not come from a general, but from a specialty engineer for the Carnegie Steel Company named Gerald E. Grulich. In 1940, observing the failure of the wire mesh systems, Grulich proposed a radical departure. Instead of a flexible net, he proposed a rigid plank. His design was a masterpiece of industrial minimalism, engineered not just for strength, but for logistics. The specifications were precise. 10-gauge steel, 10 feet long, 15 inches wide, weighing exactly 66.2 pounds. The weight was critical. At 66 pounds, a single plank could be lifted by one strong soldier, or easily carried by two at a dead run. But the genius was in the geometry. Grulich designed a system of bayonet hooks on one long edge and slots on the other. You didn't need bolts. You didn't need welding torches. You didn't need rivets. You simply dropped the hooks of one mat into the slots of the neighbor, slid it forward 2 inches, and locked it in place. A team of men could lay these mats as fast as they could walk. But Grulich faced a secondary problem. A solid sheet of steel 10 feet long would be too heavy, slick when wet, and would turn into a sailboat in high winds. His solution was to punch holes in it, 87 holes per mat to be exact. These holes, arranged in 3 rows, served 4 distinct logistical functions, creating a force multiplier effect in the design. First, weight reduction. The holes reduced the weight by 17.5%, allowing more square footage to be shipped on a Liberty ship. Second, traction. The edges of the holes were flared and stamped upwards, creating a rough, serrated surface that gripped the tires of aircraft, allowing braking action even in torrential rain. Third, drainage. Water could flow through the mat rather than pooling on top, preventing hydroplaning. And fourth, camouflage. This was the subtle brilliance. From the air, a solid steel strip shines like a mirror, but the holes allowed grass and vegetation to grow through the runway. Within weeks, an airfield paved with Marston Mat would blend back into the jungle or the meadow, becoming invisible to enemy reconnaissance planes. Grulich had designed the perfect puzzle piece. Now, the Army had to prove it could hold the weight of a war. The test came in November 1941, just 1 month before Pearl Harbor. The United States Army was conducting the massive Carolina maneuvers, a war game designed to test the mettle of a military that was still largely unproven. Near a tiny whistle-stop town called Marston, North Carolina, a unit of the 21st Engineer Aviation Regiment was given a stack of Grulich's steel planks and a stopwatch. Their orders: build a runway capable of landing a heavy bomber. The terrain was typical North Carolina sand and scrub pine-soft, shifting, and useless for heavy aircraft. The engineers leveled the ground with bulldozers and began to lay the steel. The sound was deafening, a rhythmic, metallic clanking that would become the soundtrack of the Pacific War. In 11 days, they laid a runway 3,000 feet long and 150 feet wide. General Henry Hop Arnold, Chief of the Army Air Corps, flew down to inspect it. He watched as attack aircraft slammed onto the steel deck, taxied, and took off again. The sand didn't shift. The wheels didn't sink. The steel flexed, absorbing the shock, and then settled back into place. Arnold, a man not known for hyperbole, looked at the steel ribbon and declared it the year's greatest achievement in aviation warfare. He ordered it into immediate mass production. The pierced steel plank was officially born, but the soldiers who trained on that strip in North Carolina gave it the name that would stick forever: Marston Mat. They didn't know it yet, but they had just forged the dagger that would kill the Japanese Empire. When the order came down, American industry did what it does best. It scaled. The production of Marston Mat was distributed to 30 different companies. It wasn't just steel mills. It was companies that made refrigerator cabinets, automobile fenders, and metal caskets. They retooled their presses to stamp out the uniform 10-foot plank. The logistics of the mat itself were staggering. A single bundle of mats contained 29 sheets and weighed 2,000 pounds. A standard runway 5,000 feet long by 150 feet wide required 60,000 individual planks. That is nearly 2,000 tons of steel. To the Axis, this number was laughable. The idea of shipping 2,000 tons of steel just to build one temporary runway seemed like logistical insanity. Germany and Japan were starving for steel. They were melting down park railings and church bells to build tanks. They could not conceive of a nation so resource-rich that it could afford to pave the jungle floor with high-grade steel. This was the nemesis effect. The Axis viewed steel as a precious material for offensive weapons, shells, tanks, ships. The United States viewed steel as a utility. We didn't just build weapons with steel. We built the environment with steel. By the end of the war, the United States would produce 2 million tons of Marston Mat. The cost was over $200 million in 1940s currency, equivalent to nearly $4 billion today. It was a blank check written to solve the problem of mud. And as 1942 dawned and the Japanese war machine swept across the Pacific, that investment was about to pay off in blood. The Pacific theater was a logistician's hell. It was a war fought over islands that were often nothing more than volcanic peaks or coral atolls jutting out of an endless ocean. The Japanese strategy relied on seizing existing airfields or using laborers to painstakingly construct dirt strips. On Guadalcanal, the Japanese used Korean slave laborers to chop an airfield out of the jungle with hand tools. It took them months. When the U.S. Marines landed on Guadalcanal in August 1942, they captured that half-finished airfield. It became Henderson Field, but capturing it was one thing. Keeping it operational was another. The tropical rains on Guadalcanal were torrential. The Japanese dirt strip turned into a soup of mud and coral slime. U.S. Navy fighters Wildcats and Dauntlesses were getting bogged down. Accidents were claiming as many aircraft as the Japanese Zeros were. Then, the Seabees arrived. The United States Naval Construction Battalions, the Seabees, were a new breed of soldier. They were recruited from the civilian construction trades: steelworkers, crane operators, road graders. Their average age was 37. They weren't kids. They were master tradesmen who knew how to build things fast. On Guadalcanal, and later on islands like Espiritu Santo and Bougainville, the Seabees deployed the Marston Mat. The process was a choreographed ballet of industrial speed. First, the bulldozers and other American mundane savior would scrape the jungle flat. Then, dump trucks would pour crushed coral into the strip. Finally, the mat-laying crews would move in. A well-drilled Seabee platoon could lay 5,000 square feet of Marston Mat in an hour. The Japanese commanders watching from the hills were stunned. They would bomb an American airfield at noon, clearing the runway. They expected the field to be out of commission for days. But the Seabees would simply drive out with a jeep, pull up the damaged steel planks, throw them in a scrap pile, and lock new planks into place. By 1400 hours, the airfield was launching strikes again. This was the magic carpet effect. The Japanese were fighting a kinetic war, trying to destroy assets. The Americans were fighting a regenerative war, replacing assets faster than they could be destroyed. The Marston Mat turned the airfield from a fragile infrastructure into a modular, disposable commodity. While the Seabees were proving the concept in the Pacific, the Marston Mat was facing a different test on the other side of the world: North Africa. Operation Torch, the invasion of North Africa in November 1942, brought American air power to the desert. Here, the enemy was not mud, but sand and dust. In the desert, fine silica dust destroys aircraft engines. It gets into the pistons and grinds them down like sandpaper. A dirt strip in the desert is an engine killer. When the 12th Air Force landed, they brought millions of square feet of Marston Mat. They laid it directly over the sand. The holes in the mat allowed the sand to settle, while the steel surface kept the prop wash from kicking up the deadly dust clouds. It also solved the problem of bogging. In the rainy season, the North African desert turns into a sticky clay called gumbo. German Luftwaffe units operating from captured dirt fields found their Bf-109s glued to the ground. American P-40s, operating from steel mats just 50 miles away, were taking off with full bomb loads. General Dwight D. Eisenhower, witnessing the utility of the matting in Africa, made a mental note. When he began planning the invasion of Europe Operation Overlord, he demanded that Marston Mat be prioritized in the supply chain alongside ammunition and penicillin. He knew that when the Allies landed in France, they would be landing in the muddiest farm country in Europe. The versatility of the flying carpet was absolute. It didn't just work in the tropics and the desert. It conquered the Arctic. During the construction of the Alcan Highway and the defense of Alaska against Japanese encroachment in the Aleutians, engineers faced a nightmare called muskeg. Muskeg is a boggy, frozen soil that turns into a bottomless slurry when the top layer thaws. You cannot build a road on it. The road simply sinks. The engineers used Marston Mat to distribute the weight. By laying the steel planks over the muskeg, they created a floating road. The 66-pound steel sheets acted like snowshoes for 2-ton trucks. In Greenland, at the Bluie West 1 airfield, Marston Mat was laid over glacial moraine. It provided the only stable surface for ferrying aircraft from the U.S. to Britain. Without these steel stepping stones, the Arctic air route would have been impossible, and the flow of aircraft to the RAF would have been strangled. By 1944, the Allied war machine had turned its eyes toward the fortress Europe. The planning for Operation Overlord, the invasion of Normandy, was the most complex logistical undertaking in human history. While the headlines focused on the landing craft and the paratroopers, the logistical planners were obsessed with a different problem: mud. Northern France in the autumn and winter is a quagmire. The German Wehrmacht, fighting a defensive war, relied on a network of established, concrete airfields captured from the French or built by the Todt organization during the occupation. They had the luxury of permanent infrastructure. The Allies, invading from the sea, would have nothing. They would be landing on beaches and advancing into the bocage, farmland crisscrossed by hedgerows and sunken lanes that turned into rivers of sludge under the treads of Sherman tanks. General Elwood Pete Quesada, commander of the Ix Tactical Air Command, knew that his P-47 Thunderbolts and P-51 Mustangs needed to be based on the continent, mere minutes from the front lines, to provide the close air support that was the American Doctrine Ant's answer to the German blitzkrieg. If his planes had to fly from England, their loiter time over the battlefield would be cut in half. He needed airfields in France, and he needed them immediately. This was the moment the Marston Mat became the spine of the liberation of Europe. In the days following D-Day, engineer aviation battalions moved inland with the infantry. Their weapon was the bulldozer, and their ammunition was the steel plank. The statistics of this effort are staggering. Between D-Day on June 6th and the German surrender in May 1945, American engineers constructed or rehabilitated 126 airfields in northern Europe. They laid down enough steel planking to pave a 2-lane highway from Paris to Berlin. The defining characteristic of these advanced landing grounds, or ALGs, was their impermanence. An ALG was not designed to last for years. It was designed to last for weeks. It was a disposable asset. As the front line moved forward with General Patton's Third Army, the airfields had to move with them. A concrete runway takes weeks to cure. and is impossible to move. A Marston Mat runway could be pulled up, stacked onto trucks, and driven 50 miles east to be laid down again in a new pasture. This mobility created a terrifying strategic tempo that paralyzed the German high command. German Field Marshal Rommel had predicated his defense on the assumption that Allied air power would be tethered to the coast. He believed that as the Allies advanced, their supply lines would stretch and their air cover would thin out. The flying carpet destroyed this assumption. The Luftwaffe would bomb an Allied airfield one day, believing they had neutralized the threat in that sector, only to find that the Americans had simply rolled up the steel carpet and unrolled it 20 miles closer to the German border. The psychological impact of this creeping air power cannot be overstated. German tank commanders reported a sense of total suffocation. They could not move by day because the P-47s were always there. And they were always there because they were refueling and rearming on steel mats located just behind the American artillery positions. The Marston Mat did not just change the geography of the war, it changed the soundscape. Every pilot, mechanic, and soldier who served near a PSP strip remembers the noise. When a P-47 Thunderbolt, weighing nearly 8 tons fully loaded, touched down on the steel planks, it didn't screech like tires on concrete. It clattered. It rang. As the aircraft rolled out, the interlocking hooks would flex and slap against each other, creating a deafening, metallic rippling sound that was likened to a freight train derailing or 1,000 skeletons dancing on a tin roof. This sound, the Marston clank, became the lullaby of the Allied advance. It was a noise that signified safety to the GIs because it meant friendly air cover was active. But for the pilots, the steel surface presented unique dangers. The steel was slick, especially when wet or muddy. In the rains of France, the mud would ooze up through the lightning holes, creating a surface as slippery as ice. A pilot hitting the brakes too hard would skid uncontrollably. If a plane ground looped, the landing gear could catch in the perforations or the slots, ripping the gear leg clean off, or flipping the aircraft. Furthermore, the steel was unforgiving to the aircraft frames. The vibration of rolling over thousands of steel ridges shook the planes violently, cracking welds, loosening rivets, and shattering instrument glass. It forced the ground crews to work double shifts, tightening every bolt on the airframe after every few missions. But the most terrifying hazard of the Marston Mat was the curling effect. If a pilot landed too short, or if the subgrade was too soft, the nose wheel or main gear could push a bow wave of steel matting in front of it. If the hooks failed, a 10-foot steel plank could spring loose and curl upward, turning into a 66-pound jagged steel guillotine, slicing through the fuselage or the wing fuel tanks. There are documented accounts of P-38 Lightnings having their tails sheared off by loose mats whipping up from the runway. Yet despite these dangers, the pilots loved the Mat. Why? Because it was there. It existed where no other runway could exist. It turned a muddy French beet field into a springboard for liberation. While the P-47s were clattering across France, a different scale of engineering was taking place in the Marianas. The capture of Saipan, Tinian, and Guam in 1944 was driven by a singular strategic requirement, the B-29 Superfortress. The B-29 was the most sophisticated and expensive weapon system of the war, exceeding even the cost of the Manhattan Project. It was a high-altitude, long-range heavy bomber designed to burn the cities of Japan to ash. But the B-29 was heavy 135,000 pounds, and it required massive, long runways to take off with a full bomb load. The island of Tinian is roughly the size of Manhattan. When the Seabees arrived, it was a dense jungle and sugar cane plantation. By 1945, the Seabees had transformed Tinian into the largest airport in the world. North Field on Tinian consisted of 4 parallel runways, each 8,500 feet long and 200 feet wide. To pave this massive complex, The United States did not just bring Marston Mat. They brought the entire output of the American steel industry. The Seabees laid hundreds of thousands of steel planks on Tinian. The scale of the operation was industrial terraforming. They blasted coral from the ocean floor, crushed it, graded it, and then capped it with steel. The result was a city of aluminum and steel that housed the 313th Bombardment Wing. From these steel runways, the Enola Gay and Boxcar would launch the atomic raids on Hiroshima and Nagasaki. It is a profound historical irony that the most advanced weapon of the 20th century, the atomic bomb, was delivered from a runway made of simple, stamped steel sheets hooked together by hand. The Japanese High Command was well aware of the B-29 threat, but they were completely blindsided by the speed of the airfield construction. Japanese intelligence estimated that it would take the Americans 6 months to build a B-29 base on Saipan. The Seabees did it in 6 weeks. This speed was the true secret weapon. The Axis fought a war of attrition, assuming that time was a fixed variable. If they destroyed an airfield, they calculated it would take X weeks to repair. The Marston Mat broke that equation. An airfield destroyed at noon was operational by dusk. The Americans were not just repairing damage. They were overriding the concept of destruction with the concept of replacement. Perhaps the most extreme application of the Marston Mat was in the China-Burma-India theater, specifically the airlift over the hump. The Allies needed to build airfields in China for the B-29s of Operation Matterhorn. But China was cut off from the sea. There were no ports to offload bulldozers or cement mixers. Everything fuel, bombs, toilet paper, and runway materials had to be flown over the Himalayas from India. Marston Mat was heavy. Flying 66-pound steel planks over the highest mountain range on Earth in unpressurized C-46 commando transport planes was an economic absurdity. It cost more in aviation fuel to transport the mat than the mat itself was worth. But there was no alternative. The Chinese soil was too soft for the B-29s. So, the Air Transport Command flew thousands of tons of steel planking over the hump. Once in China, the construction method was a bizarre fusion of the ancient and the modern. Hundreds of thousands of Chinese peasants were conscripted to build the airfields. They crushed rocks by hand with hammers. They moved earth with wicker baskets and yokes. And then, atop this foundation built by medieval manual labor, they laid the high-tech American steel planks. It was a visual representation of the Allied coalition. American industrial mass production meeting Chinese manpower, united by a steel zipper. It is worth pausing to appreciate the material science of the mat itself. The steel used for Marston Mat was not scrap. It was a high manganese, low carbon alloy. Manganese is a critical strategic metal. It makes steel tough and resistant to impact. It allows the steel to flex without cracking. This was essential for a runway mat. When a bomber lands, a mat must deform to absorb the energy, acting almost like a trampoline, and then spring back to its original shape. If the steel were too brittle, it would shatter like glass under the impact. If it were too soft, it would bend permanently, creating ruts that would wreck the next plane. The decision to use high-grade manganese steel for disposable runway mats is a testament to the resource abundance of the United States. Germany was starving for manganese. They needed it for tank tracks and submarine hulls. They could barely source enough for their Tiger tanks. The idea of using precious manganese to make temporary mats to be thrown into the mud would have been seen as criminal waste in Berlin. But in Pittsburgh and Gary, Indiana, the blast furnaces were running 24 hours a day. The United States produced more steel in 1944 than the rest of the world combined. We could afford to pave the world in manganese steel. This resource overmatch was the nemesis that the Axis could never defeat. They were fighting a war of scarcity. America was fighting a war of surplus. The story of the Marston Mat did not end with the Japanese surrender. The technology evolved. As the jet age dawned, the original perforated design revealed a fatal flaw. Jet engines are vacuum cleaners. They suck in immense amounts of air. If a jet engine sits over a perforated mat, it sucks up dirt, rocks, and debris through the hole's foreign object damage, or FOD, that destroys the turbine blades. Furthermore, the exhaust of a jet is hot enough to melt asphalt and erode soil. The blast from a jet taking off would blow the dirt out from under the perforated mats, creating voids that would cause the runway to collapse. So, for the Korean and Vietnam Wars, the engineers developed the M8A1 mat. This was a solid steel mat, no holes. It was corrugated for strength and used a different interlocking system. It was heavier, but it protected the jet engines. However, the original Swiss cheese mats remained in service. In Vietnam, they were used for everything except runways. They became the universal building material of the American fire bases. Sandbags were stacked against walls, made of Marston Mat, to build bunkers. They were used to pave muddy roads in the Mekong Delta. They were welded onto the sides of trucks and armored personnel carriers as hillbilly armor to detonate rocket-propelled grenades, RPGs, before they hit the vehicle hull. The Marston Mat became the Legos of war. Soldiers used them to build showers, tables, fences, and even church steeples. It was the ultimate modular unit of the American military presence. Today, 80 years after the war, the Marston Mat is still with us. If you travel to the remote islands of the Pacific, to Vanuatu, to the Solomon Islands, to Papua New Guinea, you will see fences made of rusty, perforated steel. You will see pig pens, garden walls, and bridges built from Marston Mat. In the Philippines, it is common to see driveway gates and property dividers made from the millions of tons of steel left behind by the Seabees. These rusting artifacts are the fossil record of the American logistical tsunami. They stand as a silent testament to the industrial philosophy that won the war. The Axis built monuments. The Americans built infrastructure. The Axis built wonder weapons. The Americans built parking lots. The Marston Mat was not glamorous. It didn't have the sleek lines of a P-51 Mustang or the terrifying power of a Sherman tank. It was just a piece of stamped steel. But without it, the P-51 would have been stuck in the mud, and the Sherman would have never had the air cover to advance. It was the mundane savior. It was the flying carpet. And it was the steel skin of the arsenal of democracy. To fully grasp the scale of the Marston Mat's impact, we must zoom in on the 48 hours following D-Day. The invasion of Normandy was not just a battle for beaches. It was a race for airfields. General Hop Arnold and the planners of the 9th Air Force knew that the Luftwaffe, though battered, would attempt to surge its remaining fighters to the coast to contest the landing. To counter this, Allied fighters flying from England had to cross the Channel, giving them only 20 to 30 minutes of combat fuel over the beachhead. This was the time on target, a window of vulnerability where the German panzers could maneuver without fear of being strafed. The solution was the Emergency Landing Strip, or ELS, the X Engineer Command, a specialized unit of 17,000 men, landed with the infantry. Their objective was not to take towns, but to find flat dirt. Consider the timeline of Airfield, a 1 at Saint-Pierre-du-Mont. June 6th, D-Day. Engineers fight their way inland. Snipers are still active in the hedgerows. June 7, D+1. Bulldozers begin scraping the topsoil. The ground is soft, loamy farmland useless for heavy aircraft. June 8, D+2. 1800 hours. A C-47 Skytrain touches down. In less than 48 hours, under artillery fire, the engineers had laid a runway capable of handling cargo planes. How? Because they didn't have to wait for concrete to cure. They simply unrolled the steel carpet. But the uncharted detail here is the logistics of the mat itself during the invasion. Space on the LSTs, landing ship, tank was the most precious commodity in the world. Every square foot occupied by a bundle of steel mats was a square foot not occupied by a Sherman tank or a crate of 105mm shells. The planners made a calculated gamble. They prioritized Marston Mat over heavy artillery ammunition in several early convoys. They bet that air superiority, flown from the mats, would destroy more German tanks than ground-based anti-tank guns could. It was a gamble that paid off. By D+14, Allied fighter bombers were operating from French soil, flying 4 or 5 sorties a day, creating the Schabobo terror that German tank ace Michael Wittmann and others would come to dread. The Marston Mat allowed the tactical air force to become a relentless, omnipresent swarm simply because they didn't have to fly home to England to refuel. In the Pacific, the laying of Marston Mat was not just construction. It was a martial art. The Seabees developed a technique that turned unskilled labor into a machine. They called it the assembly line method. A standard runway team consisted of 100 men. They would stage bundles of mats along the center line of the graded coral strip. Team A, the carriers. 2 men would grab a plank 1 at each end. They would run to the laying edge. Team B, the layers. As the plank was dropped, they would guide the bayonet hooks into the slots of the previous row. Team C, the hammers. A man with a sledgehammer would give the plank a single ringing blow to seat the hooks. Team D, the clippers. A final team would insert the U-shaped locking clips to prevent the mat from shifting. This process happened in seconds. A well-drilled Seabee battalion could lay a 5,000-foot runway in 48 hours. But the speed hid a complex engineering reality. Marston Mat was not a rigid pavement. It was a flexible pavement. It relied on the subgrade, the dirt underneath, for support. If the dirt was too soft, the mat would pump. Pumping was the nightmare of the airfield engineer. As a heavy plane rolled over the mat, the steel would depress, pushing the mud and water underneath it forward. This wave of mud would eventually erupt through the holes in the matting, turning the runway into a slick, unstable mess. To combat this, the Seabees used another mundane innovation: coral. Coral, when crushed and watered, often with seawater, undergoes a chemical reaction similar to low-grade concrete. It hardens. The Seabees would dredge millions of tons of coral from the lagoon, spread it, roll it, and then cap it with Marston Mat. This combination coral base, steel skin, was the Pacific equivalent of the Roman road. It was durable, reparable, and capable of supporting the B-29s that would end the war. The American way of war is often described as wasteful, and by traditional economic standards, it was. But in the logic of total war, waste is just another word for velocity. Marston Mat was designed to be reusable. In theory, you could pick it up, put it on a truck, and move it to the next island. In practice, this rarely happened. Why? Because it was cheaper to manufacture new steel in Pittsburgh and ship it 0 miles to the Philippines than it was to pay the labor cost of pulling up old mats, cleaning them, straightening the bent hooks, and rebundling them. On islands like Biak and Peleliu, millions of dollars worth of high-grade steel planking was simply bulldozed into the ocean or buried in pits when the units moved on. To the Japanese defenders, starving and scavenging for scrap metal to build bayonets, this behavior was incomprehensible. Japanese officers, interrogating captured American airmen, would often ask about the steel nets used for runways. They couldn't believe that the Americans had so much steel they could afford to use it as flooring and then throw it away. This logistics of abundance was a psychological weapon. When a Japanese commander looked through his binoculars and saw a shiny new steel airfield appear on a beach that had been empty, jungle 3 days ago, he realized he wasn't fighting an army. He was fighting an industrial avalanche. He knew that for every steel plank he destroyed with a mortar, shell, the Americans had 10,000 more in the hold of a Liberty ship just offshore. The Marston Mat became a symbol of the futility of resistance. You cannot defeat an enemy who paves the wilderness with steel just to save a few days of digging. Did the Axis try to copy it? Yes, but the results were a testament to the disparity in industrial capacity. The Japanese developed a perforated plate they called Tetsubin, but they lacked the manganese. Without manganese, steel is brittle. When Japanese heavy bombers landed on Tetsubin, the hooks would often snap or the plates would crack. Furthermore, the Japanese lacked the stamping presses to mass produce it. Marston Mat was made in the U.S. by automotive body presses machines designed to stamp out millions of car fenders. Japan's industry was more artisanal, less automated. They could not achieve the uniformity required for the interlocking hooks to fit perfectly every time. Germany also experimented with steel grid runways, notably in the Eastern Front, to combat the Rasputessa mud season. But steel was so critical for U-boat hulls and Tiger tanks that the Luftwaffe could never secure enough allocation to pave their airfields. They relied on concrete, which was slow, or grass, which was weather-dependent. This created a strategic asymmetry. The Allies could operate in any weather, on any terrain. The Axis could only operate where they had established infrastructure. In the winter of 1944, during the Battle of the Bulge, this difference was decisive. As the weather cleared, Allied fighter bombers lifted off from temporary steel mats laid right in the snow of Belgium, hammering the German columns. The Luftwaffe, forced back to permanent bases deep in Germany, could not generate the sortie rates to protect their troops. The Swiss cheese steel had strangled the German counteroffensive. There is one specific airfield where the Marston Mat played a role in American social history: Ramitelli, Italy. This was the home of the 332nd Fighter Group, the Tuskegee Airmen. The Red Tails, Ramitelli was a mud pit. Located on the Adriatic coast, the soil was a heavy clay that turned to glue in the winter rains. Without Marston Mat, the Tuskegee Airmen would have been grounded for half the Italian campaign. Archival photos of the Red Tails almost always show their P-51s parked on the distinctive perforated steel. It was this steel surface that allowed them to maintain their high operational tempo, escorting bombers deep into Germany and earning their legendary reputation. The matting at Ramitelli was laid by African-American engineering battalions. It is a poignant historical detail. Black engineers laying the steel foundation for black pilots to prove their excellence in the skies of Europe. The Marston Mat was the literal common ground that enabled the integration of the U.S. military's capability, if not yet its ranks. As the propeller age gave way to the jet age, the Marston Mat had to evolve. The original perforated design had a fatal flaw for jets: FOD, foreign object damage. The intense suction of a jet intake would pull pebbles and dirt right through the Swiss cheese holes, destroying the turbine blades. And the hot exhaust of a jet engine would blast the soil through the holes, eroding the foundation. The solution was the M8A1 Mat, a solid, corrugated steel plank without holes. And later, the AM2 aluminum mat, which is still used today. But the millions of tons of original World War II Marston Mat didn't disappear. They remained in the inventory. In the Korean War, they were used to reinforce supply roads. In Vietnam, they became the walls of bunkers, the floors of showers, and the fencing for fire bases. If you look at photos of the siege of Khe Sanh, you will see Marston Mat everywhere, not as a runway, but as armor. Soldiers used it to build hooches, laying sandbags against the steel planks to create splinter-proof shelters. The hooks that were designed to lock runways together were now used to lock bunker walls in place. It was the ultimate example of logistical recycling. A tool designed to launch bombers in 1942 was saving infantrymen from mortar shrapnel in 1968. History remembers the kinetic. It remembers the explosion of the bomb, the crash of the artillery shell, the roar of the engine. But kinetics are impossible without statics. You cannot project power without a place to stand. The Marston Mat was the place to stand. It was a humble, boring, mass-produced piece of industrial stamping. It had no moving parts. It didn't shoot. It didn't fly. But it was the flying carpet that allowed the Allies to walk across the oceans. It negated the defensive advantage of distance. It nullified the strategic ally of mud. It proved that in the 20th century, the shovel and the sledgehammer were weapons of war as lethal as the rifle and the bayonet. The Axis generals laughed at the Americans for building razor blades and refrigerators. They didn't realize that the same industrial capacity that built refrigerators could stamp out a steel road to Tokyo, 10 feet at a time. In the end, the war was not just won by the pilots in the sky. It was won by the steel beneath their wheels. By 1944, the Allied air offensive had grown so massive that it sought to encircle the Third Reich entirely. The concept was Operation Frantic, a shuttle bombing initiative. American B-17s would take off from England or Italy, bomb targets in Germany, and instead of turning back into the teeth of the Luftwaffe fighters, they would continue east, landing behind Soviet lines in Ukraine. There, they would refuel, rearm, and bomb Germany again on the return leg. It was a brilliant logistical concept, but it required American air bases on Soviet soil. The location chosen was Poltava. But Poltava was a sea of Ukrainian mud. The Soviet infrastructure was primitive, and their concrete capacity was non-existent in the region. Once again, the solution was the Marston Mat. In a feat of logistical brute force, the U.S. Army shipped 60,000 tons of steel planking all the way to the Persian Gulf, railed it up through Iran, and trucked it across the Russian steppes to Poltava. In weeks, they laid down a gleaming steel runway in the middle of the Soviet collective farmlands. When the first B-17s of the 8th Air Force touched down in June 1944, the Soviet hosts were stunned. They watched as the Americans literally unrolled an airport from the back of trucks. However, this technological marvel became the setting for one of the war's greatest tragedies of hubris. The Americans believed the location was secret and safe, deep within Soviet territory. They parked their bombers wingtip to wingtip on the steel mats, shining like silver bullion on the dark Ukrainian earth. On the night of June 21st, 1944, a German Heinkel 111 Pathfinder aircraft spotted the glint of the steel runway under the moonlight. It dropped flares. Minutes later, 75 Luftwaffe Ru-88 bombers arrived. For 2 hours, they pounded the Marston Mat strip. The steel planking, usually the savior, became a shrapnel factory. As bombs hit the runway, the interlocking steel plates shattered and flew like giant razor blades, slicing through the fuel tanks of the parked B-17s. 43 B-17s were destroyed on the ground. It was the single worst loss of American air power in the entire war. The Marston Mat had done its job perfectly. It had allowed the bombers to land. But logistics without air defense is just a target. The twisted, melted remains of the steel planking at Poltava served as a grim reminder that while you can pave the mud, you cannot pave over the need for security. While the steel mat defined World War II, the jet age brought new physics that threatened to make the Marston Mat obsolete. The Korean War saw the first large-scale deployment of jet fighters like the young F-80 Shooting Star and the F-86 Sabre. Jets are sensitive creatures. A propeller plane can chew up dirt and spit it out. A jet engine sucks everything in. The original perforated design of the Marston Mat, with its thousands of holes, was a nightmare for foreign object damage, or FOB. When a jet fired up its engine on a PSP runway, the suction would pull pebbles, mud, and loose clips right up through the holes and into the turbine blades, destroying the engine instantly. Furthermore, the exhaust from early jets was directed downwards at an angle. This jet blast was hot enough to melt asphalt and powerful enough to erode the soil beneath the mat. Pilots in Korea reported that upon takeoff, The steel mats would ripple and dance under the thrust, sometimes curling up to strike the tail of the aircraft. The engineers had to innovate again. The result was the M8A1 mat. It used the same interlocking logic, but it was solid, no holes. It was corrugated for strength, looking like a heavy steel Ruffles potato chip. This solved the FOD problem, preventing dirt from being sucked up. But it created a new logistical problem: weight. Without the holes, the M8A1 was significantly heavier. It took more ships to move it, and more men to lay it. This tension between the performance of the aircraft and the logistics of the runway would come to a head in the jungles of Vietnam. In 1965, the United States Marines landed at Si Chu Lai in Vietnam. They needed an airfield for their F-4 Skyhawk jets to provide close air support. The soil at Si Chu Lai was essentially fine, shifting beach sand a structural engineer's worst nightmare. The solution was the next evolution of the flying carpet, the AM-2 mat. Unlike the steel Marston Mat of World War II, the AM-2 was made of aluminum. It was a thick, hollow sandwich of aluminum honeycomb, measuring 2 feet by 12 feet. It was light, incredibly strong, and locked together to form a seamless, flat surface that looked like a distinct gray pavement. The construction of the Si Chu Lai airfield was a race against time. The Seabees, working in 100-degree heat, laid the aluminum planks over the shifting sands. But the sand wouldn't hold. The heavy A4 South, slamming down on the runway, caused the sand to shift underneath the mats, creating voids. The aluminum planks began to bend and crack. The Seabees' solution was pure American ingenuity. They couldn't fix the sand, so they glued it. They sprayed thousands of gallons of asphalt and resin into the sand, turning it into a primitive soil cement, and then laid the aluminum AM-2 mat on top. It worked. Si Chu Lai became one of the busiest airports in the world. The AM-2 matting was so valuable that a secondary economy emerged. Viet Cong guerrillas would sneak onto the base at night, not to destroy the planes, but to steal the aluminum planks. They prized the high-grade metal for making rocket launchers and reinforcing their tunnels. The mundane savior of the U.S. Marines was simultaneously becoming the structural support of the enemy's underground war. There is a peculiar footnote in the history of this material regarding its name. For decades, soldiers and historians have debated, is it Marston or Marston? Many official reports and soldiers' memoirs refer to Marston matting. It sounds plausible, perhaps named after an engineer or a general. But forensic historical analysis reveals this is a linguistic corruption, a drift that happened in the telephone game of global logistics. The material is definitively named after Marston, North Carolina. In November 1941, during the frantic pre-war buildup, the Army Air Corps needed a place to test this new secret weapon. They chose a flat, sandy scrubland near the tiny whistle stop of Marston. It was there that the 21st Engineer Aviation Regiment laid the first strip. It was there that General Hop Arnold saw it and greenlit the massive production run. The soldiers training there called it the Marston Strip. As they deployed to the Pacific, Marston traveled with them. But as the war dragged on, and the accent of Brooklyn and Boston and Chicago mingled in the barracks of Saipan and Okinawa, Marston softened into Marston. By the time of the Korean War, manuals were even misprinting it. But the steel doesn't care what you call it. Whether Marston or Marston, it was the same 66 pounds of Pennsylvania steel that bridged the gap between the mud and the sky. The legacy of the Marston Mat extends far beyond the military. When the war ended, the United States left millions of tons of steel scattered across the Pacific. It was too expensive to ship home. In the Philippines, Papua New Guinea, and the Solomon Islands, the Marston Mat became the fundamental building block of post-war reconstruction. If you drive through the rural provinces of the Philippines today, you will see Marston mats used as fencing for pigsties. You will see them welded together to make bridges over monsoon-swollen creeks. You will see them used as ramps for ferries and as shoring for rice paddies. In North Carolina, where it all began, the surplus mats found a poetic use. In 1950, Dare County home of Kitty Hawk and the Wright brothers used surplus Marston mats to pave the route for its mobile library. The bookmobile, the steel that was designed to launch bombers, was used to deliver books to rural children. There is even a luxury watch company today that stamps the dials of its timepieces from rusted pieces of Marston Mat recovered from Normandy beaches, selling the patina of D-Day to collectors for thousands of dollars. This reuse speaks to the quality of the material. It was a mundane savior because it was over-engineered. It was made of high manganese steel, designed to resist corrosion in the salt spray of the ocean. 80 years later, while the tanks have rusted into unrecognizable hulks, the Marston mats in the jungle are often still intact, their interlocking hooks ready to receive another plank, still waiting for a plane that will never arrive. In the final analysis, the Marston Mat is a rebuke to the great man theory of history. We like to believe that wars are won by the genius of generals like Patton or the brilliance of scientists like Oppenheimer. We look for the silver bullet, the atomic bomb, the radar, the Enigma code breaker. But the Second World War was won by the great pile. It was won by the side that could produce the most stuff and move it to the most places. The Axis powers bet on quality. The Allies bet on ubiquity. The Axis built masterpieces of engineering like the Tiger tank, which broke down after 100 miles. The Allies stamped out millions of steel sheets that could be laid down by a teenager with a hammer and could last for a century. The Marston Mat was the physical manifestation of the Allied grand strategy to smother the enemy in industrial capacity. It turned the hostile geography of the world into a friendly parking lot. It allowed the Allies to ignore the mud, ignore the sand, and ignore the jungle. It proved that in a war of machines, the most important weapon is the ground you stand on. And if the ground isn't good enough, American industry will simply manufacture new ground, 10 feet at a time, until the road leads all the way to victory.